Hi everyone, so this is a quick review of the various ways that we apply one-sided limits in Chapter 1 of Calculus. The first example is where we're looking at a piecewise function and we're trying to find the limit at what I call the border. Okay, and this is where one piece ends and the other piece begins. So when we want to do that, what we're going to do is we're going to find the limit as x approaches 4 from the negative side of my function. And then we're going to find the limit as x approaches 4 from the positive side of my function. And if they match, then the limit is going to exist. So from the negative side, that's where the values are less than 4. So I need to take my 4 and put it in here. So it's 8 minus 2 times 4. Which is 0. Okay, now from my positive side, that's this one up here because the x's are more than 4. So that's approaching 4 from the positive side. And if I put it in, I get the square root of 4 minus 4, which is the square root of 0. These two match. So my limit, my general limit as x approaches 4 of my function is 0. Now, if you were to graph this, this square root has been moved over 1, 2, 3, 4. So it's going to do that. And this is a linear function that touches up here at positive 8. And actually, the x-intercept is 4. So it does this. Okay, that is what this graph would look like. Notice, from this side, from coming in this direction, the graph is approaching 0. From this direction, if I trace the graph, it's approaching 0. So that limit does exist, and you can tell either from the graph or by the algebra. Now, before I get on to the absolute value function I have over there, let's take a look at another graph. In this case, I wanted the limit as x approaches 3 from the positive side of 1 over x minus 3, and from the negative side as it approaches with this function. So what I would do is I would draw my vertical asymptote, and you can graph this on a calculator if you want. This is just a horizontal translation 3 units to the right of the 1 over x function. The 1 over x function would have a vertical asymptote at 0, and it would pass through 1, 1, like this, like that, and it would pass through -1, -1, like that. And it just moved over by 3 spaces. Now, as I am approaching 3 from the positive side, if I trace the graph going in this direction, it's headed up toward positive infinity. So that is my limit. If I trace the graph going from the left side, from the negative side, and I trace it, it's going down toward negative infinity. So those are my limits for the right-hand side and the left-hand side. There is no general limit as x approaches 3 of this function because these do not agree. If they were both a positive infinity or if they were both negative infinity, then you could say that it's positive or negative infinity. But because these do not agree, we cannot say that. Now, the next example was the absolute value function I had over here. To work with an absolute value function, I highly recommend changing it into a piecewise function. So we're going as t approaches -1. Notice, if you take the -1 and put it in, you'll be dividing by 0 right here, which is not acceptable. So we're going to divide this up. Okay, and we're going to say it's going to be t plus 1 over some expression down here if t is greater than -1. And then it's going to be t plus 1 over some other expression if t is less than -1. So let's see what's happening here. If my numbers are more than -1, like 0, Okay, this thing is going to be a positive number in here, or if it's 1 or if it's 2, it's going to be a positive number. So it's just going to be t plus 1. Now, down here, if I put in numbers that are less than -1, like -2, I'm going to get a negative answer. -3, I'm going to get a negative answer. So this is the opposite of t plus 1. Okay, because you would get a negative answer and then make it positive. So that's how this works. Now, to check your limit, what we're going to do is we're going to reduce this. This reduces to just 1. So this limit, as t approaches -1 right here, is going to be 1. If I was to reduce this, it reduces to 1 over -1, which is -1. These do not agree, which means that this limit does not exist. Okay, so to recap, I divided it up into 2 expressions. If it's t more than -1, I'm going to get positive answers in here, and I would have just kept them. So I just keep that expression. If t is less than -1, I would get negative results in here, and the absolute value would change the sign, and that's what this negative sign does. So I wrote my expressions. Now I reduced them. This reduces to 1. This reduces to -1. If these match, then that is your limit. If they don't match, the limit does not exist. Okay? Now there's one final way that one-sided limits can be applied, and it's this way. Sometimes they'll give you a piecewise graph, and they'll ask you to do a one-sided limit and then a general limit. So here I have as x approaches -1 from the negative side of this function. So I trace my graph. As I get closer and closer to -1, I say, okay, what y value is it approaching? And it's coming this way, and it's getting close to right here. This is +1. Okay, so I just trace it from the left side because this is a left-hand limit. Trace the left side and say, what y value are we getting to right here? And that's 1. So that's my limit there. Now, for the right-hand limit, as we approach -1, I'm going to trace the right-hand side and I'm say, okay, what am I approaching? What y value am I getting to right here at -1 from the right side? And that is +3. Now again, if these two match, then that would be my number right here. But they don't match, so it does not exist. Now finally, I did the limit as x approaches 2 of my function. Now again, this is a general limit, so I'm going to check the left hand first. If I go this way, I'm getting closer and closer to +6, right at that point. Now, if I go this way from the right side, I get closer and closer to +6. They matched, so this limit is 6. So you trace it in both directions. If you're coming to the same y value, you just write it down. Okay? So I believe that's everything with left and right hand limits. Let me know if you have any questions.